Hey everybody. So we've gotten pretty good at turning a general form equation into a standard form equation for a hyperbola, for an ellipse, and for a circle. Back to the hyperbola though. We definitely want an equation in standard form for a hyperbola because from that standard form, we can dig out a lot of really great information and then plot really easily a hyperbola. Remember, the hyperbola is just a collection of parabolas, equidistant from a center, and then symmetric about foci and vertices. Okay, so I have started with two asymptotes here today. We're going to work backwards from what we did yesterday. Today I'm giving you asymptotes, and eventually you're going to write me the equation in standard form, and then I'll make it a little bit more fleshed out of a graph. So my asymptotes intersect at this center, which I see to be, about over 3 down 2. Yep, 3, 2, there we go. Now, I can find that by inspection, so just by looking at the graph, or I could look back here at my asymptotes and look at the commonalities between the asymptotes. X minus 3, x minus 3, y plus 2, y plus 2. Thinking in terms of shift rules, go to the right 3, go down 2. So translation rules, shift rules, whatever you want to call them, it's going to get you to the center at over 3 down 2. So right 3 down 2. All right, now I'm going to tell you that this hyperbola opens upward and downward. You wouldn't know that just by looking at those asymptotes. Again, let me say that again. You wouldn't know that by looking at the asymptotes. But I'm going to tell you that this one is going to open upward and downward. Okay, so I can then plot my vertices next, my two vertexes. I'm going to go over 3 and I'm going to go down 2, and then I'm going to make some sort of vertical movement. I'm going to go up some and I'm going to go down some. How much though? Well, you can figure that out from your asymptotes. Remember that the slope of your asymptotes is change in y over change in x. Remember way back from algebra 1, y2 minus y1 over x2 minus x1. Well, we just care about this 4. So 4 is going to be the amount of vertical movement one way and then the other. So I'm going to go over 3, down 2, and then up 4, like so. There's my first vertex. Did you see that on the graph? And then I'm going to go to the right 3, down 2, and subtract 4. I'm going to pop that up. There's green vertex down here in the fourth quadrant. And then those give me my two vertices. At this point, I could take my pencil and go swoop, and then swoop, and then draw in my two parabolas and have graphed my hyperbola. But unfortunately, I don't have a pencil on Desmos, so I have to type in an equation. So what I did was I typed in y squared as the positive part, and I typed in x squared as the negative part. So y plus 2 got me to the down 2 part, and x minus 3 got me to the right 3 part. So where did I get that? Really, I got it from the equations of these asymptotes, y plus 2 and x minus 3. So a few different ways you can think about it. You can think about it from, of a movement from the origin, or you can think about it, well, just look at your asymptotes and get your y component and your x component. Then I went, up 4 and down 4. So 4 is b. That's the vertical part, vertical direction, or how much space you're going up and down, how many jumps. And so I put a 4 squared under here. And then how much would I go left and right? Well, we don't even really care about plotting anything regarding that. We won't like make a point with our pencil or anything. We could, if I were seeing you in person, we'd look at that a little bit more deeply. But for all intents and purposes, we're just going to take this bottom number from our asymptotes slope, which is change in x, which is 2. So put our change in x down here and then square it, because remember these equations are b squared and then a squared. A squared always lives under your x squared. B squared always lives under your y squared. Okay, so I typed that in, and ta-da, there. Now my hyperbolas are drawn. My hyperbola is drawn, my two parabolas, and it looks really great. The only thing I still want to do is kind of figure out where are my foci. So the foci are these points that lay kind of inside your parabola, or the parabola will wrap around a foci, a focus, a focal point. Foci, again, is just the plural. So anyway, how do I come up with where those foci will be? Sorry. Okay, well, anyway, I'm still going to go over 3 and down 2. over 3 and down 2. And then where am I coming up with the square root 20? Well, the relationship between A, B, and C is the number that we're going to use for focus or for the foci. It's a Pythagorean relationship. A squared plus B squared equals C squared. So this 20 is simply 4 squared or 16 plus 2 squared or 4. 16 plus 4 is 20. So over 3 down 2 plus the square root of 20 puts me right there. And then over 3 down 2 minus the square root of 20 puts me right there as that other red focus. So that's how we would graph and write an equation in standard form, which we did over here in number 6, line 6, for a hyperbola. So that's all I have to say about that. What I'm going to do now is have you stop this video and open up the next video, and we're going to take a few quick quizzes and really then be truly experts at the wonderful world of hyperbolas.